Verify the length of the different metal wires and ensure they are all the same. Connect the Wheatstone bridge terminals X and XX to the steel wire. 5. Measure the resistance of the steel wire by the Wheatstone bridge. 6. Enter the value in Table 2. Connect the Wheatstone bridge terminals to the nichrome wire. Measure the resistance. Enter the value in Table 2. Connect the Wheatstone bridge terminals to the aluminium wire. Measure the resistance of the aluminium wire. Enter the value in Table 2. Connect the Wheatstone bridge terminals to the copper wire. Measure the resistance of the copper wire. Enter the value in Table 2. Conclusion. 1. Write the name of the wire material which has the lowest resistance. Copper. 2. Write the name of the wire material which has the highest resistance. Nichrome. 3. Write in an order the names of the conductor metals such that their resistance value per meter length is ascending. Copper, aluminium, steel, and nichrome. 4. Find the ratio of resistance of copper, aluminium, steel, and nichrome in the above example. 1 is to 1.6 is to 6.7 is to 60. 5. Write what you have understood from this experiment about conductivity of the material. The resistance of the conductor depends on the material with which it is made of. 6. Specific resistance of the material is indicated by the Greek letter P and is spelt as ρ. Task 3. Measuring the resistance of the same metal wire having the same cross-sectional area but different lengths. Choose bare nichrome wire of 20 SWG. Measure 4 meters. Mark the length of the nichrome wire 1 meter. 2 meters. 3 meters. And 4 meters. Measure the resistance between 1 meter by using the Wheatstone bridge. Enter the values of resistance in Table 3. Measure the resistance between 2 meters. Enter the values of resistance in Table 3. Measure the resistance between 3 meters. Enter the values in Table 3. Measure the resistance between 4 meters. Enter the values in Table 3. Conclusion. State the relation between the resistance and length of the wire when the conductor material and the area of the cross-section are the same. The resistance of a conductor is directly proportional to the length of the conductor. Task 4. Measuring the resistance of the same metal wire having the same length but different cross-sectional areas. 1. Choose copper wires of the gauges 30, 32, 34 and 36 SWG. Measure their diameters and confirm the gauges. Verify the length of the different copper wires and ensure they are all the same. Connect the Wheatstone Bridge terminals X and XX to the copper wire of the gauge 30 SWG. 4. Measure the resistance between the ends and enter the values in Table 4. Connect the Wheatstone Bridge terminal to the copper wires of the gauges 32 SWG. Measure the resistance between the ends. And enter the values in Table 4. Connect the Wheatstone Bridge terminal to the copper wires of the gauges 34 SWG. Measure the resistance and enter the values in Table 4. Connect the Wheatstone Bridge terminals to the copper wires of the gauges 36 SWG. Measure the resistance between the ends and enter the values in Table 4. Conclusion. 1. The resistance of a conductor is inversely proportional to its cross-sectional area. 2. The resistance of a conductor is directly proportional to the length of the conductor and inversely proportional to its cross-sectional area. 3. Above relation in a mathematical form. P equals AR divided by L. P is specific resistance in ohm meter. R is resistance in ohms. A is cross-sectional area in meters squared. L is length in meters. Exercise 2.07. Prepare simple twist joints.
Dear student, at the end of this exercise, you will be able to mark the length of insulation to be removed. In the insulation, prepare a straight twist joint in copper and aluminium. Prepare a rat tail joint in copper and aluminium.
Requirements: tools and instruments. Wireman's toolkit, 1 set. Steel rule, 300 mm. Diagonal cutting pliers. Materials: PVC insulated copper cable, 1 by 1.12, 2 meters. Cotton cloth. Sandpaper, smooth. Procedure. Task 1. Make a straight twist joint. 1. Collect 2 pieces of 1 by 1.12 PVC copper cable of 0.5 meter length. 2. Straighten the cables. 3. Mark 80 mm length on one end of each piece of cable. 4. Use the knife at an angle of 20 degrees and remove the insulation from each conductor for a distance of 80 mm. Avoid nicks in the conductor. 5. Clean the ends with the help of cotton cloth. Use smooth sandpaper if necessary to clean the conductor. 6. Place the conductors together about 50 mm from the ends. 7. Twist them tightly round each other in the opposite direction. Each twist should contain about 6 turns. Each turn of a conductor should fit closely to the adjacent turn. Eight. Cut off the excess length of the conductor with side cutters. 9. Press the sharp edge of the conductor end and smooth it. Repeat the steps 3 to 9 and make a few more joints for practice. Task 2. Make a rat tail joint. 1. Collect 2 pieces of 1 by 1.2 mm PVC copper cable of 0.5 meter length. 2. Straighten the cable. 3. Mark and skin both the cable ends for 50 millimeters. 4. Clean the conductor ends with the help of cotton cloth and emery paper. 5. Cross the bare wires at an angle of 90 degrees, at a distance of 45 millimeters from the cable end. 6. Tightly twist the ends. Remember, the twist on the wire should be uniform and close. 7. Make at least 6 twists. 8. Fold the remaining wire back on the twists. 9. Cut the excess wire. 9. Press the ends of the wire with the help of combination pliers to avoid sharp ends. Skill Sequence 1. Prepare married joint in stranded conductors.
Dear students, this lesson will help you to prepare a married joint in multi-strand conductors.
Requirements: tools and instruments. Wireman's hand toolkit, 1 set. Diagonal cutting pliers, 150 millimeters. Steel rule, 300 millimeters. Materials: PVC insulated copper cable 7 by 0.914 of 660 volt grade, 1 meter. Cotton cloth. Sandpaper, smooth, 1 sheet. Procedure: Task 1. Prepare a married joint in 7 by 0.914 stranded conductors. 1. Collect 2 pieces of PVC insulated copper cable 7 by 0.914 of length 0.5 meters. 2. Mark both cables at 120 millimeters from the cable ends. 3. Remove the insulation for 120 millimeters on both the cables. Care should be taken while removing the insulation. Do not nick or shave the conductor. 4. Open the strands up to 50 millimeters from the cable insulation. Clean the strands with sandpaper and cotton cloth. 5. Cut the center strand of both cables close to the twist, about 70 millimeters from the free end. 6. Make a binding on the twisted part of both the cables. 7. Interlace the strands, keeping the center butt. 8. Hold one of the cables in one hand and twist the strands of the other cable end over it, one by one, closely and tightly. In doing so, each strand has to be twisted half a turn at a time. Twist the strands of the other cable one by one. The direction to twist from the shoulder should be the same as the cable's original twist direction. 10. Cut the ends with a diagonal cutting pliers. 9. Remove the binding made at step 6. Complete the joint by rounding off the twisted strands with pliers. Exercise 2.08. Prepare T-joint in stranded conductors.
Dear students, at the end of this exercise, you will be able to prepare a T-joint in multi-strand conductors.
Requirements: tools and instruments. Wireman's hand tool kit, 1 set. Steel rule, 300 mm. Diagonal cutting pliers, 150 mm. Materials: PVC insulated copper cable, 7 by 0.91 of 660 volt grade, having length 0.5 meters. 2 pieces. Cotton cloth. Sandpaper, smooth. Procedure. Task 1. T-joint in stranded copper conductor. 1. Collect 2 pieces of PVC insulated stranded copper cable, 7 by 0.91. Indicate one piece as through cable and the other one as tap cable. 2. Mark the point of tap in the through cable. Mark 60 mm on either side at the point of tap. 3. Remove 60 mm insulation on either side of the through cable from the point of the tap. Do not nick or shave the conductor while removing the insulation. 4. Mark 180 mm at the end of the tap cable. Remove the insulation. 5. Open the strands of the tap cable and clean them. Use smooth 00 sandpaper if necessary. 6. Retwist the strands in the original direction. Make a binding on the twisted part of the tap cable, up to 50 mm from the insulation. 7. Untwist the through cable to provide an opening at the point of tap. 8. Insert the center strand of the tap cable in the opening of the through cable. 9. Wrap 3 strands of the tap cable around the through cable on either side of the tap point to form a shoulder on the through cable. Wrap the strands to the end and trim off the end of the strands. 11. Remove the binding from the tap cable. Wrap the center strand of the tap cable around the through cable and wrap it in the place of the binding. 12. Round up the ends with a combination of pliers or mallet to avoid sharp edges of the strands.